Hi there and welcome back to the Good Tutor Premier Prep SAT course. And in this video, we're going to start our look at the problem solving and data analysis section of the SAT math. And we're going to get an introduction to ratios and proportions, which are going to be super important really throughout the entire math section and not even just this one area or just not even within just the problem solving and data analysis section, but throughout the SAT math section. All right, so to get a quick introduction, I want to give you a couple definitions. The first of which is a ratio, which is just a comparison of two values. And the most common way we see a ratio, as you can kind of see in that example down there, is a fraction, right? And we can compare a part to part or a part to whole when we talk about ratios. And what that means is if you have, let's say, 2 apples and 2 oranges in a basket, well then if you were to compare part to part, such as apples to oranges, well, that ratio would be 2 apples to 2 oranges. But if you compared part to whole, in that same scenario, you could compare apples to all fruits that you have. Well, it would be 2 apples to 4 because you have 2 apples and 2 oranges. So it would be 2 to 4 in that case. So remember that ratios can either represent part compared to another part or a single part compared to the whole of what you have in a given situation, okay? And there again is that example of apples and oranges. Now, the other definition I want to share with you is a proportion. So a proportion is 2 ratios set equal to each other. And they're given in the form A over B is equal to C over D. And that's just those A, B, and C and D there just stand for different numbers, right? But what's important is that the relationship or the ratio between A and B is going to be the same as the relationship between C and D. And I'll give you an example. One example would be 1/2 is equal to 2/4. So while they aren't the same numbers, right, they are 4 unique numbers. If we look at A and B, which is 1 and 2, and then C and D, which is 2 and 4. I should say unique numbers, it's really 3 numbers, of course, right, because we have 2s, but they're not in the same place. One is a denominator and one is a numerator. But if we have 1/2 and 2/4, we see that the relationship between 1 and 2 is the same of that of 2 to 4, right? So 1 is half of 2, or 0.5 if we were to divide them out, and then 2 is half of 4. So they're 2 different fractions, right? But they equal each other because the relationship between that number on the top, that numerator, and the denominator is the same between the two. All right, so let's get a couple examples here of how you'll see ratios and proportions on the SAT. So this one says that a large ship is 872 feet long with a width of 147 feet. A museum wishes to build an exact replica scale model of the ship that is 8 feet long. Approximately how many inches wide will the scale model be? And on a problem like this, if they give you a conversion, you're most definitely going to use it in nearly every case that I've ever seen. If you're given a conversion, it's going to be important at some point in your calculation of the problem, right? All right, so let's see what we know. The real ship, it says a large ship, right? The real ship is 147 feet wide and 872 feet long. All right, make sure we see that too. All right, so we have a ratio there, right? 147 over 872. That's a ratio in and of itself. And that one is equal to width, we'll call W, over length, or L. But now we can extend this proportion because we're given part of the measurements for that scale model that the museum wants. And we're given that it's 8 feet long. So length, we said, is our denominator, so it's going to be there, 8 as the denominator. And then X is going to be our numerator because we don't know the width, right? That's what we're searching for according to the problem, how wide this scale model will be. So if we want to kind of rewrite this, it would be 147 over 872 is equal to X over 8. So that's our proportion, right? We took our 2 ratios and set them equal to each other. Now we need to find out what X is. So we're just going to solve for X. And this is really, you will just use what we've learned from the heart of algebra, right, to isolate that X value. And in this case, all we'll need to do is multiply that 8 to both sides. It's currently being divided. And now we'll just simplify this fraction. So if we do 147 times 8, which is 1,176. So bring that over here, 1,176 divided by 872. And you can certainly pause this video at any time to do these calculations on your own and see if you get the right answer. So then that comes out to 1.35 approximately, right? And now that's 1.35 feet, right? That is important that all of these measurements before, right, were in feet. So all of these were in feet, and we want to get them, according to this, to inches, right? And we know that, of course, every foot is 12 inches. So we'll multiply that number by 12, and we find that we get 16.18 inches. And that is going to be our final answer. So B is the correct answer. All right, let's try one more example. Riding his scooter, Jake can travel 1 mile in 5.5 minutes. If he rides at a constant rate, which of the following is the closest to the distance he will travel in 1.5 hours? All right, so once again, let's get our initial ratio here, which is 1 mile over 5.5 minutes. And then we're looking for the distance, which of course is going to be miles, right? So X miles. And it says 1.5 hours. So let's see. If we know that 1 hour equals 60 minutes, then we'll have to do 1.5 times 60 to find out how many minutes that 1.5 hours will be. If we do that calculation, right, we'll reach 90 minutes. So now 90 minutes is the time interval that we're working with in our second ratio here for our proportion. So now we have a very similar problem to last time. We need to isolate x. We'll do so by multiplying both sides by 90 because it's currently being divided, right, within that ratio. And now we've got 90 times 1, or 90 over 5.5. So 90 minutes over 5.5, or 90 over 5.5, and that will get us, so 90 divided by 5.5 is 16.36. So this one actually happens to come out to 16 as well, so about 16 miles. All right, and that is it for this video. We'll continue our look next at conversion between units.